Welcome back to AquaCulture Frontier. Today we're joined with two founders of a local freshwater prawn breeding company specialized in Macrobacterium rosenbergii, which is giant freshwater prawn. Thank you both for being here today. So to start off, we have the first question, which is, could you share which genetic breeding improvement strategies are applied in your company, such as mass selection, family selection, or marker-assisted selection?
That's a very good question. Thank you for having us here. So, at our company, one of our key production goals is to produce monosex male prawn cultures of Monobrachium rasenbergii. This is because the male prawns they grow faster, they reach larger size, and they give more consistent harvest yields compared to mixed sex population. So, to achieve this, our genetic improvement it's mainly done through selective breeding with a strong emphasis on mass selection. Amar, do you
Uh,
want to continue? Okay.
yeah, exactly. This method is practical and reliable for our scale, and we select broodstock based on consistent performance over multiple production cycles rather than single observation. Mm.
Ah, that's nice. Thank you. That gives a very clear picture on your priorities of your company. So moving on, may I know which traits are most important in your breeding program?
Um, our top priority is growth performance, specifically body weight and size at harvest. These traits directly determine farm profitability and market value. Faster growing prawns reduce culture time and also improve feed efficiency. Tash, do you want to add?
We also pay close attention to survival and robustness, but growth remains the main driver. So disease resistance and environmental tolerance, they are considered indirectly. So if a prawn grows well and survives consistently under our farm conditions, it stays in the breeding pool. However, over time, this also helps to improve the resilience of the stock naturally.
Oh, that's interesting and how your company works. Well, does your company use gene expression or transcriptomic data in decision of breeding?
At the moment, we don't directly apply large-scale gene expressions or transcriptomic tools in our routine breeding. This is because most Malaysian work in this area it is still at its academic research level, and the cost and the infrastructure required also quite high for commercial operation like ours.
Yeah, I
I
want to
see.
add a bit. However, we do able to apply targeted molecular knowledge, especially for monosex male production. While we don't run transcriptome-wide analysis, we rely on well-established sex-related biomarkers, particularly on the androgenic gland and its insulin-like androgenic gland hormone, or IAG, which is known to control male differentiation and also male type growth in prawns. Yeah.
Ah, I see. So for now, molecular analysis are largely research based. So that's very helpful. Could we move on to talking about broodstock selection? So how do you select broodstock in your operations?
Um, Broodstock selection is based on observable performance and health. We choose individuals that grows fast, reach large size, and show good survival, and we also have no visible disease signs. Reproductive performance is also critical, especially in females, where egg quality and hatch success matters.
Apart from that, because a major focus of our company is monosex male production, this is because, as I said earlier, male prawns they grow faster and they achieve higher harvest weights. So for these, sex-related biomarkers are also extremely important.
Hmm.
Do you want to continue, Miss?
Yeah, sure. The key biomarker we rely on is the androgenic gland, specifically the insulin-like androgenic gland hormone, or IAG. This hormone controls male sexual differentiation and also male type growth pattern in prawns. High IAG activity is a strong indicator of illness, and targeting this pathway allows us to produce male bias or all male population, which significantly improve farm performance. Yeah, that's all.
All right. Thank you for explaining that process. Well, let's discuss on the nursery phase next. So I've got a question. During the nursery phase, Does your company conduct analysis for specific biomarkers to ensure the post-larval quality in terms of health, growth, and survival, as well as environmental tolerance?
For routine nursery operations, we do not conduct any advanced biomarker or pathogen testing in-house. Day-to-day quality assessment is based on survival, growth performance, behavior, as well as water quality management. However, when specific concerns do arise, like unexplained mortality, poor growth, stress symptoms, or for validation under research or improvement programs, samples are sent to external laboratories. So these include government labs, universities, as well as private diagnostic centers.
Hmm, interesting.
Yeah, depending on the objective, external labs may conduct pathogen detection using PCR or qPCR, tissue histology, or targeted biomarker analysis. In research or collaborative projects, biomarkers such as digestive enzyme activity, antioxidant enzymes, stress indicator, or gene expression may be analyzed to assess health status, growth potential, survival capacity, or tolerance to environmental stress. These analyses are not done routinely but are used to selectively support decision making and long term improvement.
Ah, that makes sense. It's interesting to see how quality control is handled at nursery stage. Well, speaking of stages, have you noticed difference in strains in handling environmental stress?
Yes, from our experience with giant freshwater prawns, different strains definitely behave differently under different farm conditions. So, for instance, the selected GI Macro 2 strain, which comes from selective breeding, it shows much better survival during the larval stage compared to the control GI Macro 2 and SIR2 strain. So, SIR2 is often used as a benchmark in hatcheries because of its proven performance in survival and growth, so it's useful for comparison with newer strains.
While all strains can tolerate environmental changes, the selective line performs better under stressful conditions. This leads to higher survival, more consistent growth, and better productivity. And it's showing uh, how important genetics are for prawns resilience lah.
Hmm, thank you. Well, that shows genetic really plays an important role. So, moving on, let's talk more on disease management. So, which pathogen poses most significant risk in your operation and how they are detected in your company, either through PCR, qPCR, culture, or histopathology?
So in our company, the key viral pathogens that we face in our prawns include the Macrobrachium rosenbergii nodavirus, MRNV, sorry for that, and extra small virus, XSV, which actually causes white-tail disease as well as high larval mortality. So hepatopancreatic parvovirus, it actually slows growth, and normally detection is done via PCR or RT-PCR, and it will be confirmed with histology. Emerging viruses like Binna viruses are studied using qPCR and metagenomics, but they are not really affecting our farm as of yet. Do you want to explain further, Miss?
Yeah, sure. We do face major bacterial pathogens too, such as Aeromonas, Citrobacter, Lactobacillus, and Vibrio species. Microsporidian parasite, Enterocytozoan hepatopenae are also a major problem as it reduces growth by affecting the pancreas. Identification of bacteria and parasite is mainly done in diagnostic or research lab using culture, PCR, and histopathology.
Wow,
Yeah.
right. It's clear that the laboratory support is crucial. Next, we'd like to hear about your microbial community profiling. Could you all share more at which stage of production this method is used?
Yeah, sure. In our operation, microbial community profiling is usually carried out in collaboration with external researchers and academic partners. When profiling is needed, we mainly rely on 16SR RNA gene sequencing because it is cost effective and practical for tracking microbial community changes over time, especially compared to full metagenomic approaches.
Yes, I agree with Miss. So we do apply this monitoring at multiple stages. So at the broodstock stage, we look at gut samples and also the rearing water tank to make sure the microbial community there is stable and there is no buildup of harmful bacteria that could be passed on to the offspring. During the hatchery phase, we pay close attention to larval tanks and water microbiota because even small microbial shifts can actually have a big impact on larval survival and growth. At the grow out stage, we monitor the pond or the RAS water, sediment, and occasionally the prawn gut samples to understand how microbial communities relate to growth performance and disease issues.
I appreciate the details. Well, it's helpful to know how microbiome is monitored throughout the production. That is very good, actually. Well, let's talk about maintaining genetic diversity now. So, how does your company balance selection intensity while maintaining genetic diversity across families or lines?
So balance is very important for us. While we aim for fast genetic improvement, we try to avoid selecting too heavily from just a few top performing families. So instead, we use a structured family based approach where selection happens both among families as well as within families. Miss would explain further on that.
Yeah, we also control the number of offspring contributed by each broadstock pair, so no single family dominates the next generation. This helps us maintain enough genetic variation while still improving key traits like growth and survival. Mm.
So yeah, our goal is steady long-term improvement rather than short-term gains that could compromise our stock quality later on.
Wow, that's really nice. That provides a very clear strategy of sustainable breeding. And related to this, how do you prevent inbreeding or genetic drift in your prawn stocks?
Yeah, first we maintain a large and diverse stock population using many unrelated individuals rather than repeatedly relying on the same breeders. We carefully plan our mating and avoid reusing the same males and females across generation. Touch, would you like to explain more?
Yes, thank you, Miss. So we also try to equalize family sizes as much as possible during the early rearing stages, so genetic contributions will stay balanced. In addition, we also periodically introduce new unrelated broodstock, but only after strict health screening to refresh the genetic diversity without introducing disease risk.
Hmm, that approach seems very effective. Well, moving on, finally, let's discuss on how farming systems, whether ponds or RAS, support or limit your genetic improvement program.
So our system of choice it plays a big role in our farming. So our breeding program is conducted entirely in pond-based system. This helps expose the prawns to natural variations in water quality, temperature, and other environmental factors. Do you want to explain further, Miss?
Yeah, while this variability can make genetic evolution more challenging, it also allows us to work with larger population sizes, which is important for maintaining genetic diversity and also preventing inbreeding. Hmm.
So we always carefully monitor the performance and account for environmental effects when selecting broodstock. So the genetic gains we achieve are relevant and robust under real farming conditions.
Wow, nice. Thank you for sharing those insights. It really highlights the link between system design and breeding outcomes. Well, that marks the end of our interview. Thank you both for sharing insights in your prawn breeding program. It is impressive to have you combine selective breeding, monosex male production, and careful microbial and genetic management. Well, your approach shows how science and practical farming work together to improve the growth, survival, and sustainability. Well, we appreciate you giving us a clear picture into our modern freshwater prawn aquaculture in Malaysia.
Thank you for having us.
Yeah, thank you for having us.